All right, everyone. So the activity that we did yesterday, the conservation momentum activity, had a whole lot of data associated with it. You emailed 8 or 10 trials of position time data to yourself and to your partners so that you could plot graphs so that you could get the initial velocity and the final velocity for each trial. That would require 20 graphs in the end. A position time graph for the initial velocity, the position time graph for the final velocity of every single trial. What you see in front of you right now is the data for one trial. This is what it would look like when you received the email that had the position time data in it. It also has velocity. It also has acceleration. We don't even care about those columns. We care about time and position. Now, when you see that data, it may look exactly like this, where there are no grid marks beside it or no grid marks below it. If it is like that, you can plot your graph right now. Okay, you can plot your graph right on Google Sheets right now. But my recommendation is to actually copy and paste just the position time data into a new spreadsheet. The reason I say that is because if you go to plot a graph on this spreadsheet right now, when you don't see grid marks here, then your graph is going to go right on top of your data, and then you're going to have trouble because you're going to be covering up your data. You're going to want to work with your data and your graph, but you're not going to be able to see your data because it's covered up by the graph. Okay, what I want to do is create a new spreadsheet that has all of these grid marks there to give me a place to put the graph and still see my data at the same place. So watch what I'm going to do here, guys. This is the raw data that came from the iPhone, from somebody's iPhone yesterday for trial 14. Okay, I'm going to copy over position time data only. You could copy over everything, okay, but there's no point in copying over the velocity and acceleration. So I'm just going to copy over the first two columns, Control C. Okay, I'm going to go into my conservation momentum lab. Notice that in this assignment, there's some information here. Okay, if you forget how to submit an assignment, here's some instructions. The graphing instructions, the essential graphing instructions that I'm giving you today are here as well. Also, the podcast from yesterday is posted. I'll post this podcast later on today after I get it saved and uploaded. I'm going to click on the activity here. I'm going to create a spreadsheet. Okay? This is not what you're going to actually hand in. I'm just going to create this spreadsheet so that I can plot my graph. There it is. It's going to be a blank spreadsheet. Now, in that spreadsheet, I'm going to paste the data that I just copied. Again, you don't have to do this step. You had a spreadsheet with the data in it. But notice in this spreadsheet, I've got all this space to put my graph so that it's not going to cover up my data when it gets plotted. Does that make sense? All right, so let's plot a graph here. Remember, it's trial 14. Let's call it trial 1, though. Okay? So I'm plotting data for trial 1. Here's how you're going to do this. And again, the essential instructions for this are attached to the assignment itself as well. I'm going to highlight the data. I'm going to click Insert, and I'm going to click Chart. So you're going to insert a chart. It's much like it is plotting a graph on Excel, to this point at least. This is when it becomes a little bit different. Okay, what are you going to select in here? Kenton, you're going to select Charts here. So you've inserted a chart. You're not going to click Start because the one that you want is not in that Start menu. You're going to click Charts, and then you're going to scroll down here to Scatter Plot. Then you're going to click the first scatter chart. Take a look at my graph. My graph at this point does not have a title. It doesn't have axes labeled. It doesn't have lines of best fit. I'm not going to worry about that right now. I'm just going to click Insert. Okay, I'm going to move it over here, which I can actually do in this graph because I have space to move it to. But I've done something with my data. There we are. There we are. All right. Now, I'll tidy it up with a title and axes a little bit later on. Right now, what I want to do is get rid of the data that's useless. That data that was taken before the car started moving, right? We press Start. The car wasn't moving yet. Okay, I want to get rid of that. I also want to get rid of data that was recorded after the trial was over. So in other words, maybe the car hits something. Oh, we press stop after the car hits something or something like that. We can see quite clearly here what data is not relevant. It looks like from 0 to 0.6 seconds is irrelevant data. It's extraneous data, data that we don't want. So what I'm going to do is leave that graph up there. I'm just going to highlight 0 to 0.6. I'm going to right click and I'm going to delete those rows. It's gone. Now I can see up here, there's some data that was taken after the trial should have been over. Let's say the last 2 points, we want to delete those. So let's highlight those, let's right-click those, and let's delete those 2 columns. Sorry, those 2 rows, I should say. So there's my graph. It shows my initial velocity right here. It shows my final velocity after the collision took place right here. Now, we cannot do 2 lines of best fit on the same graph. Okay, we can't do that. So what I want to do is actually delete this graph now. I want to delete this graph after I see where the cutoff is. Okay, the cutoff between initial and final velocity is right here. Okay, that's 1, 2, 3, 4, 5. My first 5 data points are my initial velocity. My last 5 data points are my final velocity. So let's delete this. Let's delete this chart. Let's highlight just my first 5 data points now. Okay, does that make sense? Now let's plot a new graph of just those 5 data points. Okay, insert the chart. Scatter plot, same way as you did before. There's my graph. That make sense? I'm going to move that over. Now I'm going to do essentially the same thing for my last bunch of data points. I'm going to insert a chart over here. Again, it's my scatter plot. It's my first option within scatter plot, and it looks like this. So this is my initial velocity. This is my final velocity. Now, I can tidy this up a lot, easily. Okay, let's click here, top right-hand corner, Advanced Edit. The name of my chart is Position versus Time. We'll say Final Velocity, just so we remember that it's after the collision. And we'll call it Trial, what was it, 14, I think? Whatever trial it was, Trial 1, Trial 14, whatever. Okay, so there's my title. I'm going to scroll down to label my axes. My horizontal axis should have a label of time in seconds. Now, beside axis, you're going to click on that and select vertical. That should be position. Now, I have to find what that velocity is. Scroll down right to the bottom. You want to add a trend line here, right at the bottom. It's a linear trend line. Looks like this. Still doesn't have the slope there, but that creates a few more options below that after I add that trend line, Kenton. Okay. There's an option here beside label. It says custom. I want you to click on the drop-down menu, click use equation. All of a sudden, right up here in the top right-hand corner of this graph, the equation for the graph has appeared. Y is equal to 0.2x plus 0.198. The slope of that graph is 0.28. That means the final velocity of those cars after the collision in trial 14 was 0.28 meters per second. That make sense? Okay, let's get the initial velocity. Let's go back to my other graph. Let's update that, by the way. Let's go back to my other graph. I'll go through the exact same procedure here. Advanced Edit. The title will be Position versus Time. This was for the initial velocity. If I could type, it would be nice. And that was for, I think we said trial 14, wasn't it? Whatever, again, whatever it is. Okay, scroll down to label your axes. My horizontal axis will be time in seconds. And I've got to click on that drop-down menu, select the vertical axis. That's going to be position, and that's going to be in meters. Scroll down right to the bottom. Your trend line, which says none right now, is going to become linear. Gives you an option to scroll down even further now. Beside label, click use equation. And now we can see that my initial velocity was 0.68 meters per second. So update it. You get two graphs now for trial 14. We can see in trial 14, the initial velocity was 0.68. We can see that the final velocity was 0.28. Does that make sense? Now, how long has that taken us to do? A few minutes, right? You can see in the top corner here, 10 minutes and 47 seconds. Okay? Well, 10 minutes and 47 seconds times 10, that's a lot, right? But if you're just doing this, if I'm not having to explain this every single time, after you get the hang of it, like it's going to go and you're going to be able to do each one in 90 seconds maybe. Seriously, like each trial in about 90 seconds. And I'll tell you what I'll let you do, just to save yourself a little bit of time here. Okay. Because this is really data, right? We want the initial and final velocities. For these graphs, I don't even really care if I get a title and our axes labeled. Okay. I mean, that takes half the time, right? Is literally typing this stuff in. Okay. Get your graphs, get the slope, and then enter the slope, which is your initial and final velocity, into your data table for initial and final velocity. Does that make sense? Does that make sense, guys? Okay. What I would like to see, though, just so that I know you didn't copy your data table, okay? Just so I know you didn't copy your data table from somebody else, so that you actually went through the process of plotting the graphs, which is important. I don't need to see these graphs, these 20 graphs, in your actual write-up. Okay, I need to see the one graph for VF versus VI, that last one, but I don't need to see these in your actual write-up. What you can do here, sorry, let's go into the classroom here. What you can do here, guys, is obviously you're going to create a document. That's going to be your actual activity, your actual lab. And it's going to come up in just a second here. Just humming along, just humming along. It's going to be there in a second. There's our document is up now. This is what you're going to actually submit as your assignment. This is where you type everything, right, in that document that you've created here. Just taking a while to load. I'm just going to cancel that. This is it. Okay? But when you submit your assignment, okay, when you click turn in, you will also be turning in these spreadsheets, any spreadsheets that you've done like this with your graphs. Just leave the graphs right there. Okay, I don't need to see it in this. I don't need to see it in this document, okay, the document that you're handing in. I just need to see these spreadsheets if I choose to look at those spreadsheets to know that you've plotted those graphs. Does that make sense? Again, because it's not part of your formal write-up, if you didn't put a title on it, that's fine. I might not even look in yours. I might not. But I might just, well, if you don't have a spreadsheet there, if I see that there's not even a spreadsheet there, I might start thinking, wait a second, well, how did they get all this data if there's no spreadsheet? So, or if you have, you know, if something looks really similar to somebody else's, and then I might have a look at your spreadsheet just to know that you've plotted your graphs yourself. Okay, does that make sense? That make sense, guys? All right. Now, in the end, you are going to have to plot a graph to include in your write-up, and that graph is going to be a VF versus VI. Let's create another spreadsheet here. Okay, once we have VF and VI, remember that data table that I showed you yesterday, we're going to have to plot a graph with that data and then include that in our assignment. I'm going to show you how to do that in just 1 second here. There it is. So here's another spreadsheet here. Actually, that's going to be this one down here. So let's say we had, for our final and initial velocity data that looked like this. It was initial velocity first, right? Let's make that column a little bit wider here. Make this one a little bit wider. And let's say we had, I'm going to make up some numbers here, just some real simple numbers here, okay, guys? Oops, those aren't the numbers I want. Okay, there's my data for initial and final velocity. I want to plot that graph now. This is the one that I want to include, remember, in my actual lab write-up. So let's highlight it. Let's once again insert. Let's insert a chart. Okay, you're going to select under the Charts tab there, Scatter Plot. Select the first one. Now, what you can do is insert that right now and then add your title and stuff, or you can click Customize right now instead of going back and doing that later. Get your chart title in there. It's going to be final velocity versus initial velocity. Or final velocity as a function of initial velocity or something like that. Your horizontal axis will be initial velocity. And that's going to be in meters per second. My vertical axis will be final velocity. And now I want to scroll down and get my trend line. It's a linear trend line. And I want to use the equation there, insert it. You can see the slope of this graph is 2. Now, that doesn't correspond to a velocity now, right? That corresponds to m1 over the total mass, right? Which is something that you have to calculate separately. But that's the slope of this particular graph, okay? Let's click it, highlight that graph. Let's click Control-C, which is going to copy. Let's go back into my document here. And let's paste that into that document by clicking Control-V. And there's my graph. Make sense? Now, if you want to, since you've got to create in your spreadsheet, if you want to actually just do a table once and not type it in your spreadsheet and type it into your document, what you can do, oops, I don't know what I did there. What you can do is just create it in your spreadsheet, highlight that entire graph, or sorry, highlight that entire data table, copy that, Control-C. Now under my data, I can just go back in, click Control-V, now my data table pops up. That make sense? So this should be a relatively short process for it. It's not going to be a 10-minute lab write-up. Okay, it's going to be, when all is said and done, it's going to take you a fair little bit of time. But once you get the hang of it, first couple trials, once you get the hang of plotting those graphs and separating the data, it shouldn't take all that long. Okay, I mean, it might take you an hour to do this lab write-up. Okay, and that's quite a bit of time. But we have a total of 5 days to do it as well, right? Counting yesterday when we did it. Yep. Yes. Yeah. Remember your data table and the explanation that I gave you before you did your lab yesterday? The data table had initial velocity, final velocity. Now these numbers for initial and final velocity that we have right there, they come from those other graphs that we plotted, right? They come from, where were they? Not that one. They come from these graphs, right? Your data table comes from these graphs that I have here. that came from my original data, right? Remember, I got my original data, then I deleted all the extraneous data points, and then separated it into initial and final velocity right here. So this is what gives you your initial and final velocity for that table that you should see right here. So we had trial 14, whatever, we'll call it trial 10, whatever, trial 11, whatever. Your data for this table, for that trial, comes from this spreadsheet. I'm sorry? For the graphs, I mean? Yeah. These graphs here are simply to get initial and final velocity. You can include those right on your write-up if you want, but you don't have to. Okay, you can just leave them right there in the spreadsheet that you created to plot those graphs. Copy, get the initial and final velocity from the slope of the graphs, and then enter them into this table. So there's one of the trials right there that we just did right there. Then you're going to do that again for another trial to get initial and final velocity. Then you're going to do that again for another trial to get initial and final velocity, and so on. Okay, so there is a total of 2 graphs for each trial. And then once you've done each trial to get initial and final velocity, there's going to be one graph that is not D versus T, not position versus time, but final versus initial velocity, which is going to allow you to get the value of the slope, which you're going to compare, as we said yesterday, to M1 over the total mass. No. One graph here, total, to including your write-up, because this includes trial 1, the velocity initial for trial 1, trial 2, trial 3, trial 4, trial 5, trial 6, right? To get this data point, you're going to have to plot 2 graphs. To get this data point, you're going to have to plot 2 graphs. To get this one, you're going to have to plot 2 graphs. But once we've got the data from those 2 graphs here, here, and here, then you're going to just put it together and form one graph there. Okay? Yep. If you remember from yesterday, we said, we'll go through this one more time quickly because that was a bit confusing, and you saw that for the first time ever yesterday, that analysis. This graph is a straight line graph. It's very clearly a straight line graph, right? So any straight line graph has the equation y equals mx plus b, right? The y-axis here is the final velocity. Agree? M is the slope. So all I'm doing right now is tailoring that equation y equals mx plus b to this particular graph. The x-axis is the initial velocity. It's actually the initial velocity of car 1, right? There's no y-intercept. B is the y-intercept. It's not there. There is no y-intercept. So then what we do is make an assumption. We're going to assume that pi equals pf. We're going to assume that conservation of momentum is valid here. M1 v1I plus 0, because the second car didn't have a momentum before the collision took place, right? Equals mvf. mvf because there's only one object after the collision. They stuck together, right? One mass. Now we're going to rearrange this to solve for vf. Vf becomes equal to m1 over m times v1I. If you have trouble with that rearranging, just come and see me and I'll help you to get that. I solved for vf here, by the way, because that's what I solved for over here. Now we're going to cross off vf because it appears in both. I'm going to cross off v1I because it appears in both. I'm left with the slope is equal to m1 over m. So you've got the value of this slope. We just got it from the graph. It's 2, right? I want you to calculate separately the value of m1 over m from the masses that you measured. and then I want you to compare those two numbers. They should equal each other if the law of conservation of momentum is valid, right? We made an assumption that it was valid. If these two numbers equal each other, then our assumption must have been correct. If they're not equal to each other or within 10%, then our assumption that we made, this one right here, must not be correct, which is the real purpose of the lab, right? To see if that assumption is correct, to see if PI equals PF.